Alright everybody, so hi, hello. This is, I'm going to do a video solution for problem 25 from homework 3A, because that was requested. So let's do this. Alright, so number 25 basically says that a boat takes 3 hours to travel 30 kilometers down a river, then 5 hours to return. How fast is the river flowing? So hopefully most people understand that rivers, right, they have a current, they flow in one direction, and so I'm drawing my diagram here, and in my diagram I'm saying that the river is going to flow to the right here. So because the time only takes 3 hours going in one direction and then 5 hours going back, I'm going to assume that the velocity of the boat was pointing in the same direction as the velocity of the current, and that's what allowed the boat to appear to be that allowed the boat to be moving much faster because it was given help from the current. These two vectors added up. Where when the velocity of the boat was going opposite the direction of the current, the velocities were pointing in opposite directions. I'll say that scale is not properly proportioned here. So if I make this then my origin where the boat starts, during the first part, when it goes all the way to the finish line here, the displacement is positive 30 meters because it goes to the right. Where when it goes back, the displacement is going to be negative 30 meters, and that takes 5 hours to do, as opposed to 3 hours going there. All right. So now what I'm going to do is I'm just going to try and establish some kinds of relationships. What kind of relationships can I get? And then from these relationships, I'm going to kind of start to combine things until I can find out what just the velocity of the current is, because that's my main goal, is to find this. So all right, so one of the first things I'm going to do is just using the fact of relative motion. I'm going to say that the total velocity going, so when they're going there, I'm going to call this all the first thing. So this is T1, and then I'll call it the second thing for going back. So for the first thing, so the total velocity for at part 1 is going to be, well, it's going to be VB pointing to the right plus VC, because that's pointing to the right as well. I'll forego the vectors and I'll use symbols like positive and negative. So all right, so there you go. That's one relationship right there. And then I also know that the total velocity is going to be just the displacement divided by the time. So again, this is the displacement, this is the time, so I'm using D1, T1. All right, so those two things are relationships right there. And then I'm going to do the same thing for the opposite direction. So I'm going to say the total velocity for 2 that's going back, well, for 2, that's going to be VB pointing in the negative direction. VC hasn't changed, it's still pointing to the right. So that's going to be negative VB plus VC. And then again, using the definition of kind of average velocity, it's also going to equal the displacement over the time. Time 2 is 5 hours, and then D2 is negative 30 meters, because again, it goes to the left. All right. So there's that. Now, I'm going to basically, these are equal to each other, right? They're the same thing, so I can set these things equal to each other. So let's do that over here. So this is going to be D1 over T1 is equal to VB plus VC. And then I'm going to isolate VC or VB by subtracting both sides by VC. So it's going to be D1 over T1 minus VC is VB. So again, here's another kind of new relationship. I got VB here. I'm going to do the same thing with these equations. These, whoops, made a mistake. That should be right here. I had a 1, should be a 2. because that's the total velocity at 2. All right, so once again, I know now those velocities are the same, so therefore I can set these equal to each other. That's what I'll do over here. So this is going to be d2 over t2 is equal to negative VB plus VC. There we go, we got that. Oh, sorry. So now I'm going to do the same thing here. I'm going to isolate VB. So in isolating VB, I can add VB to both sides. So that'll cancel here. And then I got VB plus D2 over T2 equals VC. Subtract both sides by D2 over T2, and that'll give me VB is VC minus D2 over T2. I think I got that. All right. So now both these things are equal to VB. So if this is equal to VB and this is equal to VB, then I can set these two things equal to each other, and that's what I'm going to do next. So I'm going to go over here and over here. Those two things are going to be equal to each other. So we got D1 over T1 minus VC is equal to VC minus D2 over T2. And let's see. So a couple things I can do is add VC to both sides. So it'll cancel here, but it'll add up here. So that'll give me, let's just take this step by step. D1 over T1 is equal to VC plus VC is 2VC. And I got minus D2 over T2. So then next I'm going to do, I'm going to add D2 T2 to both sides. So that cancels with that. And then I get D2 over T2 plus D1 over T1 is equal to 2VC. Okay, so well, basically now all I got to do is divide both sides by 2 and plug everything in. So I'm going to say D2 over T2 plus D1 over T1 divided by 2 is equal to VC. And now I'll plug everything in. D2, that was negative 30. So this is going to be negative 30 divided by, I think T2 was 5 hours. So these are in kilometers per hour. Yep, 5 hours. Plus D1 was going to be positive 30 because it just went to the right instead of to the left. Divided by, this one was 3 hours. And then divide all this by 2. So if I do that and plug all that into my calculator, I got negative 30 divided by 5 plus 30 divided by 3. So negative 30 divided by 5, I can even simplify this. Negative 30 divided by 5 is negative 6 plus 30 divided by 3 is 10. So that gives me 4. And then 4 divided by 2, that gives me a current of positive 2 meters per second. And this makes sense to me because it's pointing to the right. So it's pointing in the positive direction. That's the way I said my current was going to point. And 2 meters per second also makes sense. Yeah. All right. So, yeah, hopefully that helped. And all right. Bye-bye.